So now we're going to have the second warm-up. So the second warm-up is going to be, we're going to go back to expanding actually. So if I want to expand that means I want to get rid of the bracket. What I do is I have a number in front of the bracket. I multiply into the bracket. And I get 3 times 4 is 12x. And 3 times minus 2 is minus 6. Let's do another one. So that's kind of like an example 1 on the warm-up. Example 2 on the warm-up is going to be 3x plus 7. I multiply in, and I get 12x squared plus 28x. Example 3 is going to be 8x to the 5 times 3x to the 4 plus 4. This one's a bit more involved. I'll explain what it involves though in a bit. 8 times 3 is 24. X to the 5 times x to the 4 is x to the 9. And 8 times 4 is 32 x to the 5. Okay. Keep that in mind. So what we're going to be doing now is we're going to be doing something called the opposite. So it's called, when we get rid of the brackets, we call that expanding. And when we create the brackets, we call that factoring. So we're kind of putting it in a different notation, a different way of looking at it. So let's say, for example, I had 12x minus 6. And we're going to learn a way of doing it called common. So we'll call that example 4, kind of. And the way we do common factoring is we start off by looking for something in common. So what's common between 12 and 6? So you could do the factor trees that we did before, or you can just look. And it turns out that that's the greatest common factor. So we're going to write the greatest common factor in front. We're going to open up a bracket. And then we're going to take each term and we're going to divide it by that common factor. So I took the two terms, I put the common factor in front, and then I'm going to divide each term by that common factor. And what we get is 6 times 12 divided by 6 is 2x, and 6 divided by 6 is 1. That'd be the common factor of that one. I paused because I realized I was trying to do something, but it didn't work out the way I was hoping. I made a mistake. Let's see if anyone can figure out what that mistake was. Let's say we had, sorry, wrong way. $12x squared plus 28x. So what we're going to do is we're going to find a common factor. Now, the first common factor is, so between 12 and 28, I could divide them both by 2 or 4. 4 is the bigger one, though. So 12 divided by 4 nicely, 28 divided by 4 nicely. So 4 is going to be the greatest common factor. And then what I do is I'm going to take each one of those things. So we had our messed up the color scheme I was going for. Divide each of them by 4. And it's going to be 4. It's going to be 4 times 12 divided by 4 is 3 x squared, and 28 divided by 4 is 7 plus 7x. So just to be clear, going from there to there is what we're going to call factoring. And then going from there to there is what we're going to call expanding. And this is factored form, so we start there, we factor in order to become factored. So this is now factored form, and if we expand it, it would go into expanded form. Okay. So this one now you know enough to do it by yourself. So pause it and try it. The greatest common factor of 10 and 15 is 5. We divide each of them by the 5. And we get 5 times 10 divided by 5 is 2x. And 15 divided by 5 is 3. And that's that in factored form. Sometimes we actually can't really factor. So what we have here is 7 and 11. The greatest common factor is just 1. So in theory, we could bring a 1 out in front. And that would be 7x plus 11. We could divide both sides by 1. And then we would get 1 times 7 divided by 1 is 7x. 11 divided by 1 is 11. We get 1 times 7x plus 11. And we haven't really changed it. The thing in the bracket looks exactly like we did at the beginning. So we're not actually ever going to do that. This is not a useful common factoring. It's a trivial factoring. So what we would say is that this cannot be common factored. So this over here cannot be reasonably common factored.